So we would like to find all unit vectors that are parallel to the line that goes or that contains the points 1, 2, -1, and 2, 1, 3. So first of all, let's recall a few things. When do we say that a vector is unit? So U is called unit if its magnitude is equal to 1. Okay. Now, what is an easy way to produce unit vectors? If V is a non-zero vector, then if we scale it by the reciprocal of its magnitude, that's a mouthful, right? But still, if we scale it by that number, then that becomes a unit vector. That's basically all we need. And to solve this problem, it would be a good idea to draw a picture that shows us what is going on here. So without trying to suggest that any proportions are being observed here, let's suppose that we have this line that goes through these 2 points. So you have 1 to 1, 1 to -1 actually, and 2, 1, 3. And pretty much you want to find all vectors that satisfy 2 properties. They are parallel to this line and they have length 1. Now, how many such vectors are there? Are there infinitely many? Are there finitely many? Are there any to begin with? And the answer is pretty straightforward. So if you take a line segment that has length 1, then that defines easily 2 such vectors. So it will be this vector and it will be the opposite vector. Let's recall that a vector can originate anywhere. So if somebody says, oh, how about this vector? Then this vector is simply the same as the first one that we drew. Okay, so there are 2 such vectors. So how do you find these vectors? Let's call these points A and B. So what is the vector AB? What are the coordinates of the vector AB? So you will have 1 minus 2, 2 minus 1, and -1 minus 3. To find the coordinates of a vector, we subtract the coordinates of the point of the point of origin from the coordinates of the terminal point. So that is going to give us -1, 1, and -4. Okay. So all we need to do is, as we say, normalize the vector, which is exactly this. So what is the magnitude of this vector? The magnitude of this vector is going to be square root of -1 square plus 1 square plus -4 square, which is square root of 18. And this means that this vector, so we divide by square root of 18, or if you like more precisely, we multiply by the reciprocal of square root of 18. So this vector will be one of the 2 vectors, and then you have to take its opposite. So the final answer is that these are precisely the 2 unit vectors that are parallel to the line, and they're parallel to the line because they're parallel to a vector, a non-zero vector that is inside the line, and they're also unit. They're unit because we normalize the original vector. And that's all. Thanks for watching.